This one's about finding limits when you don't have a picture or when you just don't want to use a picture. Because sometimes estimating limits with a picture is not the most accurate way. And so there's got to be a way to do it some other way, like with algebra. And so the first method is going to be called numerically. And that just means with a table. Now this is the most cumbersome, it's the longest way, but it's a way that sometimes you have to use if the other methods that I'm going to show you today just don't work. And so let's say you have the limit as x approaches 1. I'm just going to do a really easy short example right here. I have a function that's pretty simple, just a linear function, and I'll need to draw you a table. So here's a nice little table, it's all neat, and these are going to all be x values and these are going to be function values. Since I'm approaching 1, I'm going to put 1 in the middle, and I'm going to pick x values that are right around 1 on this side and right around 1 on this side, like 0.999 and 0.99 is kind of close, and 0.9. Now notice I'm getting closer and closer and closer. Maybe I'll do 2.001 and 2.01 and 2.1. And so those are getting farther and farther away, but you'll notice 2.1 is still pretty close. So what I'm going to do is plug these values into this function and see what this function is kind of looking like based on this table. So if I plug in a 0.9, 2 times 0.9 is 1.8, plus 1 is 2.8. If I put in a 0.99, 2 times 0.99 is 1.98, plus 1 is 2.98. If I do a 0.999, 2 times 0.999 plus 1 is 2.998. I don't know what this value is, but I'm looking at numbers to the right. So here I've approached from the left. Now let's approach from the right. So these aren't even close to 1. How about we pick 1.01 and 1.001 and 1.1. Okay, so 2 times 1.1 plus 1 is 3.2. And put in a 1.01 right here. 2 times 1.01 plus 1 is 3.02. Plug this one in over here. 2 times 1.001 plus 1 is 3.002. So we can see that from the left we're approaching 3, and from the right these numbers are getting closer to 3. So this limit must be 3. And that's how you find a limit with a table. You see what numbers these are approaching and what numbers these are approaching. Somebody might be saying, well, if I just stuck a 1 in there, I'd get a 3. And that's true. And that's because this function does not have a hole in it. 2x plus 1 is just a linear function. And so the limit is actually the function's value. So that would have worked on this one. But if the function had a hole in it right here, you wouldn't know the y value, and you would have to make a table from the left and from the right. But since this one is continuous, sticking in a 1 and finding the y value would work. Now that's called direct substitution. So if I asked you the limit as x approaches 1 of 2x plus 1, the next method, this is method 1, this is method 2, is just direct substitution. Just literally take this number and put it in right here, and most of the time direct substitution works. So there's my answer. So if direct substitution works, that's all good, and it's the easiest way to do it. So sometimes though direct substitution does not work, and that's kind of what this lesson is about, finding limits with algebra. This is what to do when direct substitution fails. So if direct substitution fails, we're going to move on to method number 3, which is factor. So let's say I gave you the limit as x approaches 3, x squared minus 9 over x minus 3. Let's try to do direct substitution this time. So here's some direct substitution. This would be a 3 squared, which is a 9, minus 9, all over, plug in a 3 here, 3 minus 3. So direct substitution gives me 0 over 0. Now, some people would say that anything divided by itself is 1. Some people tell me that 0 over anything is 0. Some people would say this is undefined. Well, the truth is this is an indeterminate form of this limit. It's undefined, but this does not work nevertheless. 0 over 0 is undefined, so we can't do that. So when direct substitution fails, we must factor this function first. So this can be rewritten like this. And you'll remember from some pre-calc that you can cancel these or divide out these. And I have a new function. The limit is x approaches 3 of x plus 3. And direct substitution will work now. So since direct substitution failed originally, I factored, canceled out the whole, and now I don't have a whole anymore, and direct substitution will work. 3 plus 3 is a 6. Let me write that a little neater. And so what I have here are two functions. I have this function, and I have this function, and they both look really similar. As a matter of fact, I'm going to draw. So you know from Algebra 1, y equals x plus 3, that is just your standard linear equation. Slope of 1 goes through the y-intercept of 3, looks like that, except this is a perfectly diagonal line, straight line. Now this, you might say, wow, that looks kind of strange. Actually, it looks just like this, except where x equals 3, there's a hole. So 1, 2, 3, there's a hole in that one. So this function right here would follow this same path, except right here there's a hole because this function is rational, and when x equals 3, this fraction has a 0 in the bottom, and then it keeps going. So that's why we weren't able to use direct substitution here, because when you plug in an x equals 3, there's not a value there. But if you cancel the hole out, then this function now turns into the red line, and you can use direct substitution with the red line because there was no hole there in the red line, because this is just a regular linear equation. So the fourth method is called rationalizing the numerator. And this is the longest method that involves algebra. So let me write an example. So if I try to direct substitute, which is the first thing you always want to try, I'm going to stick in a 0 here and here, and I would have the square root of 3 minus the square root of 3 all over 0. So this is 0 over 0 again, and direct substitution has failed. Well, I don't know of any way to factor this, which is my first step after direct substitution fails, but I don't know how to factor this. So I need to go to rationalizing the numerator, and usually you want to rationalize the numerator when you see square roots. That's usually a giveaway that you're going to be rationalizing the numerator. Now, what you're going to do is multiply the top and the bottom by the conjugate. All we're going to do is say that this expression is equivalent to one that I'm going to multiply the top and the bottom by 1. So this was my original, and if I multiply the top and the bottom by 1, nothing will change. So let me show you how to multiply by 1. So anything over itself is 1. So that's why I didn't change this, because all I did was multiply this by 1. Now I picked a conjugate. I picked a very special way to write 1. I picked the conjugate of the numerator. Conjugate means same numbers, only different sign in the middle. So what happens when you multiply conjugates is the outer and the inner go away. When you FOIL these two together, I'm now going to get the limit as x approaches 0. First times first, square root of x plus 3 times the square root of x plus 3 is just x plus 3. Outer and the inner go away, last times last. It's going to be negative square root of 3 times positive square root of 3 is negative 3. And when I multiply it, when I distribute this into the bottom, I'm going to get something crazy. So I'm just going to leave it, and you'll see why I'm just going to leave it in this form. Okay, so now on the top, x plus 3 minus 3 just leaves me with x. On the bottom I still have this x, and that's why I did not want to write it in there, because usually when you rationalize the numerator, this step always happens. It'll save you some time if you don't have to pull that back out to be able to cancel it. Because these will now cancel. I have a 1 left up here. Remember, this is not a 0, this is a 1. Okay, and just like up here, after you factor, then direct substitution works. Well, here, after you rationalize the numerator, direct substitution works. So you can take this 0 and put it in everywhere you see an x. My answer is 1 on the top. That's all that's left over. Down here, square root of 0 plus 3 is the square root of 3. Well, what is 1 plus the square root of 1 over square root of 3 plus square root of 3? That is going to be 1 over 2 square roots of 3. And some people would not like you leaving the denominator having a root in it, so you would fix that by multiplying the top and the bottom by square root of 3. And this answer would then be square root of 3 over 6. But I would probably accept this one. AP will accept this one, so I will too. And that's it. Those are the ways that you can find a limit with algebra or a table.